Okay, so also I'm going to mention this over here. We've got the learning standard, which there was a first one where we were doing the equivalent forms, right? And we'll get back to conversions when we're reviewing for our test. But the one we're working on now is I'll learn how to solve quadratics in one variable. And there's three ways that we're focusing in on right now this unit. Using the quadratic formula. Not part of our current lesson, but we spent about a week on the quadratic formula. Solving using the square root symbol. We did that late last week, where you solved the equation directly. There was no bx term. And then today and yesterday, we've been honing in on solving by factoring. So we're using old skills with the current thing to do the new thing. Hey, I think I already asked everybody to put the Chromebooks away. Make sure your cell phones are put up. Thank you. Don't worry, I won't immortalize you in YouTube. All right, so this was just practicing in standard form, which we've already done that. Let's go to this one where they have an example of solving by factoring. Now, there are three kinds of factoring that we focused on in late December and that we reviewed a little bit 2 days ago. And one of them was the greatest common factor. Oh, lo and behold, this problem is that problem. Okay, so let's jump over here. That was random. You know it randomly populates the questions here. We have x squared plus 4x is 0. Okay? And you'll notice that that's not a trinomial, so we're not going to do an x. It doesn't have three things. It doesn't have three terms. It's not a difference, so we're not going to use the difference of two squares strategy, so look for a common factor. And you'll notice they have letters in common. So we can take the x out, the smallest exponent x. You guys remember this stuff? We were fairly good at this, and y'all did GCF in middle school. So the x comes out after we divide it out. If we got 2 there, we take 1 away, there's only 1 left here. There's only 1 there, we took 1 away, there's none there. And then this, the one we took out is in front. And you only know it's good if you multiply it back, you get x squared, you multiply it back here, you get 4x. So you know that this is an equivalent form. Why is factoring useful? Well, there's this thing called the zero product principle. And I will, the zero product principle. And y'all know it even if you don't. Okay, you have a number, it's any number. I'll call it A. And you have another number, we'll call it B. And they're multiplied together. And they're equal to 0. Now you guys have learned multiplication very well in elementary school. Y'all remember doing your times tables and things like that, flashcards? I do flashcards with my own son. He's in 3rd grade. And he's struggling understanding that multiplication. If you know all the multiplication, you will automatically know all the division. If 3 times 5 is 15, what's 15 divided by 5? Well, you know it had to have been 3. So if you knew the times tables, you know all the division. So I'm doing flashcards whenever I have a moment with this division. Anyways, here we have 2 numbers, and I don't know what they are, but they're multiplied together, and I do know what they equal. They equal to what? To 0. So what has to be true? It's kind of like Clue. Somebody died, so you know somebody had to have done it, right? So one of those numbers has to equal what? 0. If you know anything about multiplication and numbers, somebody had to have equaled 0. So that's why we can reach this conclusion that if 2 numbers are multiplied together equal to 0, we know that either A had to be 0 or B. It's also possible they both go to that. But look at this, now we're looking at our potential 2 different solutions. So factoring puts us in a situation where we have a number times another number. I don't know what either one is, but we know that they're equal to 0. So when we reach this conclusion and say, okay, here's the first number, and x plus 4, this quantity is the second number, they're multiplied together, they're equal to 0. We know that one of them has to be. So I'm going to say, well, what would make this equal to 0? Well, this one means x just itself was 0. In this situation, if x was 0, what would this whole bubble equal? 0. No, 0 plus 4. This bubble would equal 4. but that one would equal 0, and 0 times 4 would equal 0. Okay, so my point is this, that this case will give you a different scenario for each bubble, but it doesn't matter. So if x was 0, then this one would be 4. 0 times 4 is 0. It still works. Now in this case, if x was negative 4, we know that this one would be negative 4, the A, and this one would be 0, and negative 4 times 0 is still going to be 0. So that's why we reach those conclusions. That's why factoring kind of works for solving equations of this type. Because you get two things multiplied together, and we've arranged it by making them equal 0. Most of the time we have to move things over. In this case, the problem was already there. All right, so that's an example of using the zero product principle and the greatest common factor to get it in the format of the zero product principle. Two things multiplied together equal to 0, and then we get our two solutions. Here's another one. It's almost easier. I'll just skim it real quick. So we've got x, we'll take it out. Factor out an x there, factor out an x there. They both have at least an x. So you get x minus 1 equals 0. Well, what would make that factorization equal to 0? Just x is 0, right? You didn't have to modify it. But here, to make the whole thing equal to 0, you would need x equal to positive 1. And that's what works out. And if I plug in a 0 into the original equation for that one, if I plug in, you get 0 minus 0 is 0. And if I plug in a 1, 1 squared is 1, minus 1 is 0. Still works out. So any way you slice it, you can check those solutions there. All right, so that is using the greatest common factor. This one would also be the GCF, actually, in disguise. Wow, they're trying to give me a lot of them. This one is more like difference of two squares, so let's take a look at it. Here's your backup example of difference of two squares. And, you know, I'm probably going to give you a few of these on your test. I'll probably give you, if I remember what I did in the past, you're probably going to have one of this kind on your test, 1 or 2. You'll probably have 1 or 2 of the difference of two square kind, a couple of the regular X method kind, and then 1 or 2 of the one that I'm going to teach you today. Okay? So all of them will be represented on your test equally. So, all right, here, what's the problem with our equation off the bat? It's not equal to 0. So we've got to arrange things and make it equal to 0. So what's one thing we can do to get us closer to making it equal to 0? JT, you got an idea? Subtract 2, yeah, and not only subtract 2, but subtract 2 from the 1 on the other side. Very good, because those are alike. Oh, in the nick of time. Oh, they didn't forgive you?
I just came in.
No. They sent an email to all teachers saying that tardies would be not applied until 7:45 today. Hopefully they didn't put it in as a tardy. I'm just, you know, looking at it. The rain and stuff, and there's probably some traffic issues, there always is. I know it's pouring hard when I was driving. Alright, let's continue. What's another thing we could do? We want the right hand side to equal 0, and Miss Chapman told us to take 2 away on both sides, which was perfect. I don't know, what else can we do? We gotta do something about the 5x, right? What do we do? Let's go, YouTube famous, let's make it happen. Because I have so many followers on YouTube. How do I make 5x equal to 0? Minus 5x, that's right. Minus 5x. And in fact, yes, you would take away 5x on this side as well, because it's on, that's just what they are. They're like terms. All right, so we get 0 on the right. And on the left side, this washes. 5x minus 5x is gone. Now we just have x squared, and 1 minus 2 is negative 1. Okay, so to summarize, for you that just walked in, there are 3 ways we're focusing on solving these quadratic equations. We also did the conversions on this test, but 3 ways we solved quadratic formula, using the square root, and now factoring. Okay, this one is all review in a lot of ways because we did factoring last semester. So when you have your test, and this is the last lesson, other than this is just to be wrapping things up and tying up loose ends. I think I pretty much taught the meat of everything at this point. When you get your test, you'll have certain types of factors you'll be accountable for. Greatest common factor in solving and getting the answers. Difference of two squares, solving and getting the answers. The x, and then the one I'm going to teach you today. Okay? So all of those problems will be on there. You can't just know one or two. You need to know all of them. All right, here, we're down to two terms. We got it equal to 0. We have x squared minus 1. Well, there's only one possibility. Now, well, there's kind of two. We did look at GCF, but if there's a difference between the two terms, clearly there's not a letter in common, so it's not a GCF. So the only other option we really have is difference of two squares, because it's two items. So let's check. Is x squared a perfect square? Is there a number that you can multiply by itself to give you x squared? X times x? Could I square root it? Will also tell you if it's a perfect square. If you can square root it cleanly, it is a perfect square. Same thing with the 1. 1 times 1 is 1. So we can plug it directly into that formula, which isn't listed here, but I'll write it down. A squared minus b squared is equal to a minus b, a plus b. So whatever the first perfect square is, the root of that, you put it there and you put it there. You have a plus and you have a minus. Doesn't matter the order. I could have had the minus here and the plus there. Doesn't matter. And then use the second number. The square root of 1 is 1, so that's 1 and 1. We're done with the factorization. We just need to consider the solutions. Okay. What would make the first bubble equal to 0? What could make this first bubble equal to 0? What number for x? What you got, Tia?
-1.
X equals -1, correct. How about the second bubble? Huh? +1 or +1. Those are our two answers. Now I'm gonna tie something in. Okay, I'm gonna show you one other thing. Because the directions are gonna say things like solve by factoring. But the reality is, if it's a multiple choice question, nobody's gonna care what technique you actually use to solve it. Now, on the milestones, there are times when you have to write out your explanation. That time it would matter which technique you use. But here, I'm gonna show you something. We had x squared minus 1 equals 0, right? Well, you might notice, what's missing from this trinomial? Which term?
X value.
X to the first. When is it okay to solve using the square root? When there's not an x to the first, right? Well, is that the same answer? Yes, it is. Might even be easier to do. Depends how you look at it. Okay? Again, I'm not really going to test you on which strategy you use, but the danger is there's only certain times you can use some strategies. There's one strategy you can use all of the time. Now, first off, to do like factoring, you have to follow all the rules of factoring. And some things are unfactorable, because it requires them to all work out nicely with whole numbers. To do the difference of two squares, you've got to have a perfect scenario, a difference of two squares. However, to do the quadratic formula, it works every time. There are no restrictions. Did you hear that? Okay, great. The quadratic formula will work with every type of problem I give you. You can only do the difference of two squares at certain times. You can only factor certain polynomials. You can only solve using the square root if bx is 0. All right, I'll move on. Last one, we'll do one of the x kind, that ain't it. Sure, we can do this one. It's already equal to 0. There are three terms here. It's a trinomial. I'm going to point out something. What is A? Who knows what A is? where it is. I didn't ask you where it lived. Ask what is it exactly? What is A? A is 1. Now that doesn't matter as much with this technique, but it will matter when I teach you the new thing for today, when we do bottoms up, right? So all we're gonna do, it's already set equal to 0, is we need to think of what will multiply to be negative 32, and what will add up to be negative 4. Things that multiply to be this, and they sum, add or subtract up to be this. Well, we got 32. If you're stuck, divide by 2, it's 16 and 2. I mean, I could divide that by 4 and multiply by 4, so I'll get 4 and 8. That might be all the combinations. Maybe. Is that it? Right now working great. Well, do any of them, are any of them far enough away to be 4? These two are far enough away to be 4. I could configure it to get them to add up to 4 with a subtraction or something. So let's do that. Negative 8, positive 4. So we know it factors to be x minus 8, x plus 4. But the answers are actually going to be positive 8 and negative 4. The opposites of what you've got in your x. So if you want to skip this step, you can, but if you're not convinced, do the factorization and think about, I got to find out what would equal 0. Remember, if you can't remember, the whole thing's got to equal 0. So if I accidentally said that the answer was negative 8, you have to be able to plug it in and make this thing equal to 0 on your calculator, and negative 8 won't work. Only positive 8 will work for this moment. Does that make sense? If this is truly one of the answers, 8, then I should be able to do this. 8 squared minus 4 times the 8 minus 32. And my calculator, if I plug all this in exactly like that, has to spit out a 0. Otherwise, your answer is incorrect. That's another legal cheat. I just gave you a legal cheat. You're going to have multiple choice answers on most of the questions on the test, right? If they're solutions, they're supposed to equal zeros. What should you be able to do with each answer? Plug it in, and it should equal what? 0. That's a Algebra 1B life hack right there. It's 8 and negative 4. That's the answer. And I'm verifying it's the answer by saying if I plug the 8 in, it would equal 0. If I plug the negative 4 in each of these bubbles, you should get the same thing, 0. You will. Okay, I'm going to delete this. We're done reviewing. Was that a good review? Is everybody a little stronger about what we did yesterday? Yeah. Okay, cool. All right, so next up, I've got to find something. Let me hit pause. Otherwise, it takes an hour for these videos to upload, if they do at all. All right, we're back. Found what we needed to find. So I'm going to erase this one because we already have an x method one there where a equals 1. Notice what's in front of the x squared. Some other number, not 1. This is the last factoring technique solving question we have. So let's see, we've got 3x. This is this bottoms up. You can say it's the x where a is not 1. Okay, so we've got 3x squared plus 7x minus 3x plus 1.
Does that say equal 1?
Huh?
Does that say at top of bottom?
A is not. So it's an equal with a line through it, so it's not equal. This marker's dying. Oh, a lot of black. Oh, well. Okay. So obviously the first thing we need to do is we need to move everything over. We will take away the 3x. Goodness gracious. All the markers are bad. Oh well. Minus 3x. Minus the 1. The 3x has to go with its like term. Now we're ready to do the thing. 3x squared plus 4x minus 4 equals 0. These are all canceled to 0. This makes that. 7 minus 3 is 4. That's how many x's we have. And we have a trinomial, 1, 2, 3. There's not a GCF. There's no number that will divide out of all of them. There's not a letter in common. You have to have letters in all of them to match. And this number is not a 1, it's a 3. It's something else, right? So now we can proceed. At this point, we will go with bottoms up. That has a bx term. We cannot use solving by square root. Okay, so I'm saying we can solve by factoring, but what's another way we can solve this equation? What? We can't use a regular x. We're doing bottoms up. We will use the x, but it's the modified one because that's not a 1. Huh? No. Well, there is a factoring technique called the box method, but I didn't teach you that. That's the multiplication. Which solving technique can we not use? Pick one of these that we can't use. We cannot solve by square root. Why? No, because that's there. Okay, so we can't use solving by square root, but which way will work every single time? The quadratic formula. I'm not going to do the quadratic formula, but let's say you couldn't factor this correctly, you were lost or something. Guess what you could do? You could use the quadratic formula on this. It's a multiple choice test. I'm not going to know any different. Now, do you need to know it for the word problem stuff that they put on the milestones? Yes. But when you can find, cheats to get you through, use them. All right, so we multiply. This makes negative 12. This number is a 4, but in this case, since we multiplied, what do I have to add to my sides? Who remembers? Come on, guys, this is the one new thing for today. What do we have to add to the sides since we multiply? You gotta bring the division to both of the answers that you're gonna get. Now, the things that multiply to be 12, I don't know. 12 and 1, 6 and 2, 3 and 4. Which of these could be 4 apart? 6 and 2 could be. So let's try that. I'll put a 6 and a 2, but I have to go 6 minus 2 to make that happen. Now double check. 6 minus 2 is 4. 6 times a negative 2 is negative 12. That's it. Okay, what do we have to do next? Does anyone remember?
Don't you divide the 6 and 3?
Right, use your calculator, use the N over D button. And if you're bad at fractions, use the N over D button on your calculator for both of them to verify that these are reduced. This one is reduced, so that we're done. This one is a positive 2. So now we're going to have our factorizations. I'm doing the extra step you may not need. We'll say x plus 2, and then bottoms up, bring the 3 up. 3x minus 2, that's the factorizations equal to 0. Now guess what? I can work this out, but the solution for that is just going to be the opposite of that one. So our actual answers are negative 2 and positive 2/3. Think about it. If 3x minus 2 was equal to 0, if I wrote that whole bubble out, I'd add 2, and then I would divide by 3. And you get x equals 2/3, and it's positive. The opposite of what we had right there. Now, if you want to do that extra work, you can. Well, remember, it's the opposite of your reduced solutions in the x. Okay? Are we good? Are we good, sleeping? Okay. I'll do one more of this style, and then I'm going to call it a day. Okay? And then you guys work on your assignment and whatnot. Let's do, I don't know. Do you guys feel like you know what to do? All right, let's try one more. I want to see you work it out. So if Sleeping Beauty isn't up and doing, we're going to have to keep doing examples. Let's go. Every person needs to do this. So to get us set up, I hope we're on pace here, guys. We got to add 9x and minus 9. So So our new equation will be 4x squared minus 7x plus 3 equals 0. And that is what you're going to have to bottoms up to form this x. Okay. So we're probably going to have to do one more example after this one. You do multiply and get 12. The middle number goes right there. And on these problems, you divide by what you multiplied by, the lead term. The things that multiply to be 12 and add to be 7, you got, again, we have 12 and 1, 6 and 2, 4 and 3. The only ones that could get to 7 are the 4 and 3. So I'm going to go 4 and 3, and they're both negative to add up to negative 7. Now you plug the N over D, but plug this into your calculator using the N over D button. That is reduced. It'll verify that is what you should have. This one, though, is negative 1. So we can skip to our answers. What are the answers? They're the opposite, positive 1 and positive 3/4, the opposite of what we got right there. So you could just say positive 1, you'll hit the comma button, you'll slap in a 3/4. You don't have to put the plus signs, I'm just emphasizing for effect. So 1 and 3/4 are going to be the actual answers. If they asked you to factor it, it would be x minus 1, 4/3, or 4x minus 3. The factorizations would be negative. But we're not doing that right now. We're just using this skill to get to the answer. Hopefully that explains. Now look, guys, we'll try this one more time, but y'all have got to be all in. I need to see everybody trying to do the thing. Show me that you've picked up what I've put at you, thrown at you here. Here's your new problem. It's got to first get equal to 0. Then you'll do the bottoms up. Use the opposites as your answers. Good luck. All right. You minus this thing. So we have 3x squared plus 2x minus 8 equals 0. From here, we're going to solve our x. We'll multiply there. Goes kind of like this. That is negative 24, positive 2. You're going to have to divide by 3 in both pieces. The two numbers, 6 and 4. Now you could have used 20, you got 24 and 1, 12 and 2, 8 and 3, 6 and 4. All sorts of things make 24. But the only of these that are 2 apart is these two. So that's a minus, that's a plus. And then you got to test them. You got to reduce them using your calculator. That's 2. So our answer is going to be negative 2, positive 4/3. Okay, you're going to have 50 minutes. Now, it's due today in class. What I'm going to put on here. You got 7 problems in 50 minutes added to what you had yesterday.